All right, y'all, we're looking at the review for our first DCA, looking at the first 6 weeks worth of stuff right here. Okay, and on this first problem, number 1, we are asked to solve this equation. Now, this equation has a set of absolute value bars inside of it. So our step number 1 for all of these problems is always going to be to get that part that I just highlighted completely by itself. Okay, so that means on this equation, we're going to have to get rid of the minus 3, and we're going to have to get rid of the 2 that's out in front of it. So first, we're going to add 3 on both sides, get rid of that. At this point right here, it is very, very tempting to try and distribute that 2 and make it 2x plus 4 instead, okay? But that's not how it works. Absolute value bars don't work the same as regular parentheses. So anytime you have a coefficient in front of it, you have to divide it out, okay? You have to divide both sides by 2 because distribution doesn't work with absolute values. Okay, so we've got that absolute value equals 7. Okay, after we have the absolute value part completely by itself, that is where we split this into 2 separate equations. Okay, we're going to split it in the positive version and the negative version of this equation. The positive version looks like this. We've got x plus 2 equals 7. Okay, the negative version is where we take that same x plus 2 and we make it equal to negative 7. Okay, both of these equations are pretty easy to solve. Okay, both of these equations are pretty easy to solve because on both of them we're going to do the same thing. We're going to subtract 2 on both sides. Minus 2 and minus 2. Our first solution is x equals 5. And on the other one, we go minus 2 and minus 2. Our other solution, x equals negative 9. Okay, so that means our final answer, we put those two things in our set notation. We say that x is part of this set that's either 5 or negative 9. All right, so there's our answer for number 1. Roll on down to number 2. Number 2 is asking, when we look at this graph, what equation is being shown? Okay, so the first thing I look at when I'm thinking about an equation is obviously it's got this V shape to it, right? So it has to be an absolute value equation. If it has that V shape to it, I'm also going to look at the location of the vertex right there. And I'm going to look at the slope of these lines. The legs of that V have a certain slope to them, okay? So if I'm going, for example, from that vertex up to this point, I can clearly see that I'm going up 1 and over 1, up 1 and over 1 every time. So that means our slope is 1. And if our slope is 1, then you're not going to have any coefficient, okay? If our slope is just up 1 and over 1, up 1 and over 1, we're not going to have any coefficient out in front of it. I also noticed that this is the normal V shape. It's not flipped over, reflected upside down. So this particular function right here is just going to be the absolute value of something. There's no coefficient and no negative sign. But when I look at the location of the vertex, I can see that that vertex is located at the point 3, 4. So that means it's been moved to the right by 3 units, and it's been moved up by 4 units. Okay? If we're moving to the right by 3 units, it's very tempting to think that it's going to be x plus 3. But you got to remember that insiders lie. That's what we always said, right? Insiders lie. So just because we move to the right, that actually means we're going to put minus 3 on the inside of our absolute value bars. Okay, absolute value, x minus 3. And then we also moved up by 4, so that's going to be plus 4 right there. So we got absolute value of x minus 3 on the inside, plus 4 on the outside. That's what this function is. Number 3, describe in words how the graph of the second function relates to the graph of the first function. All right, so the differences that I see in this second one is we've got plus 4 on the inside, and then we've also got minus 7 on the outside. So what we're going to do here is we're just going to describe what transformations happened in the second one compared to the first one, okay? So when we have a plus 4 on the inside, we just got finished saying that insiders lie, right? Plus 4, it's really tempting to say that that's going to move to the right by 4, but since insiders lie, we know that plus 4 means left by 4. And then the minus 7 on the outside means that we've moved down by 7 units. All right, so left 4 and down 7. Number 4, what is the inverse of the function? All right, if we're going to find the inverse of a function, we have to follow 4 steps. Step number 1 is to rewrite it as a y equals. Step number 2, swap the place of x and y. Okay, remember that definition that we gave of inverses was that they have the opposite domain and range of each other. So in the equation, algebraically, we're literally going to trade the places of x and y. Instead of y equals 1/4 x, we've got x equals 1/4 y minus 5. Okay, the next thing to do is to convert this into a y equals again. Okay, we have to get it back to a y equals situation. So the first thing I'm going to do to get this y by itself is I'm going to add 5 on both sides. Remember that if you're doing something like this, you add 5 on the right side, it all disappears, but on the left side, x and positive 5 are not like terms. So you have to leave them separate from each other as x plus 5. You can't put those things together. And then we've got 1/4 y. Okay, the way we described these problems, when you have a fraction times a variable, to make it no longer a fraction, you're going to multiply both sides times the denominator. Okay, multiply times the denominator. And what it does, since a fraction is division, what happens is you're dividing by 4 right there and multiplying times 4 right there. And all you're left with is just 1y. Okay, on the right side, all of that disappears. You're left with just 1y. On the left side, you need to make sure that everything gets divided or gets multiplied times 4. Okay, everything on that side all gets multiplied. So it's 4x plus 20. Okay, our last step is to just fix the notation. Okay, the inverse of this function, f inverse of x, 4x plus 20. Rolling along to number 5. This one gives us an absolute value function, but it's not actually asking about the function, is it? This one is asking about the domain and range of the function. Okay, and this is something that I talked about way back at the beginning of the 6 weeks, right? This is something from way on back. So the domain is talking about the x values, and that means how far to the left and how far to the right does this function reach? When I ask that question about this one, I can see that we've got one arrow that points to the left and one arrow that points to the right. Okay, our domain is going to be every single possible value. Okay, our domain is going to be negative infinity to positive infinity. Every real number x value is going to be part of that domain. Okay, how far to the left? Well, it goes infinitely far to the left. It also goes infinitely far to the right. When we talk about range, though, we're talking about how far down to how far up does this function go. Okay, in the y values, what is the lowest that it reaches? Well, again, we look at the arrows. Okay, those arrows are both pointing downwards. So that means there is no bottom of this range. The bottom of the range is negative infinity. It keeps going. However, there is a place where this function tops out. And the place that it tops out is at this point right here. That y value of negative 3 is where it tops out. And since there's not an open circle up on top of it, we're going to give it a square bracket right there. So there's your domain and range. Number 6. This one gives us two functions and it asks what is f minus g. Okay, literally all we got to do, and I've seen a lot of people overthinking this one. Okay, all you have to do for f minus g is take this thing minus that thing. I'm talking negative 3x minus 6 minus, okay, there's f, minus g, 14 minus 2x. Okay, after this, remember when you're subtracting, it's better to go ahead and distribute this negative to both of the things in the second set and then just combine like terms, okay? So that first one stays the same, negative 3x minus 6 minus 14, and then we've got a minus distributed to another negative, turns into plus 2x. All right, and now the name of the game is just combining like terms, and we know how to do that. Okay, we've got negative 3x plus 2x. That's negative 1x. And then we've got negative 6 minus 14 minus 20. There we go. Negative x minus 20. All right, number 7. This is one on the DCA that trips a lot of people up. Okay, this one is asking for the minimum and maximum on a specific given interval. Okay, let's talk about what it means on the interval negative 5 to negative 2. Okay, now we know that the x values of negative 5 and negative 2 are right there and right there. Okay, what this means for our question, when it says what is the maximum and minimum on that interval, that means in between negative 5 and positive 2, or negative 2, excuse me, this part in the middle is the only part of the function that we're worried about. All of this other stuff, all of that over here doesn't matter. All of this over here does not matter. We are only concerned with what is happening on this one middle piece of the function in between right here and right there. That is all we're worried about. And it's asking the question, what are the minimum and maximum value? That is talking about what is the highest y value and what is the lowest value in between those two vertical lines. Okay? So when I'm looking at that, I can tell that the highest value is going to be this one right up here. That's the highest up that we reach in between those two vertical blue lines. Okay, so that y value is 7. So our maximum on the interval is 7. The minimum on this interval is the lowest point right down here. And that y value is 1. So your max is 7, your min is 1 on that interval. On to the back of the page, number 8. All right, we had a question like this on when we talked about inverses just the other day. The domain of a linear function is that set. The range is that other given set. The domain and range of the inverse. Okay, the way we define inverses is that they have opposite domain and range of each other, right? So that means if we have the domain of the original, that's going to be the range of the inverse. If we have the range of the original, that's going to be the domain of the inverse. Okay, so let's start with finding the domain. On the inverse, what we're looking for is the range of the original one. Okay, if that was your original range, then this is your inverse domain. X such that x equals negative 12. Okay, y'all see the relationship between this domain in the inverse and the range that was in the original? Okay, it's the same thing. We're just talking about x values now instead of y values. That's the only difference. And it's the same thing when you look at the domain of the original. Okay, the range of our inverse is going to be the same thing, except this time it's y values. Y such that y is less than 6. Okay, look at the relationship between the domain and range of your original and inverse, those two things I highlighted in yellow, and look at the two things that I highlighted in red. Okay, all we did was we took the original domain and range and made them trade places. Rolling on down now to problem number 9. Problem number 9 is asking us to solve this inequality. Okay, if we are solving an inequality, then that means something very important for us. All right, so we look at this problem and we can see that we've got a greater than symbol. Okay, we've got a greater than symbol involved in this problem, and that tells us that at the very end of this, we are going to have two solutions, and they're going to be exclusive of each other. Okay, we have a greater than, that means great or. This is going to be an or problem. When we get to our final answer, it's going to be an or answer. Okay, other than that, the solving this problem right here is very similar to the other absolute value equation that we did a minute ago. Okay, we're going to split it. The absolute value part you can see is already by itself. So all we got to do now is split it into the positive and negative version. The positive version looks like this: 3x minus 8 greater than 19. Pretty similar to the original. Well, the negative version looks like this: 3x minus 8. This time we have to flip the sign around. Less than negative 19. Okay, that's part of it, is making sure you flip that sign around. All right. Solving the inequalities themselves, pretty simple. We're going to add 8 on both sides. Let's see, that would give us 27. And then divide by 3. Okay, it's the same thing for this one. We add 8 and then divide by 3. This one ends up as a fraction, but that's okay. Okay, our final answer is to take that original thing way up here at the top. We recognized it was a greater than, so it was going to be an or. Our final answer is just joining those two things together, those two solution sets together with the word or. So x is greater than 9 or x is less than negative 11 over 3. Problem number 10. Very similar to the one we just did, except this time we have a less than sign up here at the top. And that means for us, actually, hang on. We can't use that yet. We have to have the absolute value part by itself. That's my mistake. Okay? We need to get this absolute value of x minus 6 by itself. And anytime you have a coefficient in front of your absolute value, you have to divide it out. You can't distribute that. We have to divide by 2 before we can do anything else. Okay, so now our problem is absolute value of x minus 6 less than 20. Now we can look at that less than sign. It's not 20, it's 10. Now we can look at that less than sign, and we can say that our answer, our final solution, is going to be an and. Okay, when we have a less than sign, that's less than. Okay, that's how I learned it in high school, and it's dumb, but you remember it. Okay, you got great or on the first problem we did, and less than on this one. Okay, so we'll go, we split it in the positive and negative version. Positive version, x minus 6 less than 10. The negative version, x minus 6 greater than negative 10. And we solve by adding 6 on both sides. Our two solutions, we join them together with the word and. Problem number 11 is another straight up equation solver. All right, right up, exactly what we've been talking about. We start by getting that absolute value by itself, plus 7 on both sides. Absolute value 4x plus 12 equals 36. We split it in the positive version. 4x plus 12 equals 36. And the negative version. 4x plus 12 equals negative 36. All right, positive version and negative version right there. Solve those two equations. The process is going to be the same on both of them. You're going to subtract 12 and then divide by 4. Subtract 12. Oh, and then divide by 4. So we've got those two solutions, and our solution set ends up looking like this thing right here with the curly brackets. 6 and negative 4 are the two parts of that solution set. All right. Problem number 12. The domain is asking for the domain and range of the parent absolute value function. Okay. We know that the parent absolute value function, I'm going to draw a quick little sketch of it right here. It makes that V shape. It bottoms out. The vertex is right there on the origin, and then it goes back up, and it looks about like that. Okay. The domain, pretty simple. Okay. The domain is the same as every single absolute value. Negative infinity to positive infinity every single time. The range is the one that goes from bottom to top. Well, this thing bottoms out at 0. So it gets a square bracket, but then it goes up to infinity. Okay, that's what it looks like in interval notation. It also asks for our answer as inequalities. Okay, so if we're going in inequality form, the domain is that x is any possible real number. Okay, you could say something like this. X is in between negative and positive infinity. That would be a good answer, something like that. You could also, for the range, you could say something like all the y values are definitely greater than 0, but they're also equal to 0. Okay, that's what that looks like as an inequality. Okay, this little thing right here, this range starting at 0 up to infinity, well, that's the same thing as these y values down here, right? Y values starting at 0 and any number greater than that is included in that range. So there we go. Oh, we're running out of time. Problem number 13. Write the equation with a reflection over the x-axis, shifted right 10 and down 9. Okay, we can do that. If it's got a reflection over the x-axis, a reflection over the x-axis means there's a negative sign. If we go to the right by 10 units, remember that insiders lie. That means we're going minus 10 inside. And if we're going down by 9, that's on the outside, so it's minus 9 outside. Here's what all of that looks like all put together. We're going to have a negative sign out in front of it. On the inside, we're going to go x minus 10. On the outside, we're going to go minus 9. There we have it. In interval notation, problem number 14, x is less than or equal to negative 9. Okay, so think about this. If x is less than or equal to negative 9, what is the highest end of that number? What is the highest number that could fit into there? Well, the highest number is 9. Okay, so that means it's going to be the second number of your interval. Since it's got an equal sign as part of this, less than or equal to, it's going to get a square bracket. And you ask yourself, is there any bottom of this interval? Is there any lowest number that fits? Well, no, you could put 0, you could put negative 10, you could put negative a billion. All of those would be less than positive 9. So that means negative infinity is the bottom of it. Our last one. Find the inverse, then use the inverse to fill in the missing values. On your paper, it gave you different numbers in this column right here. Okay, on your paper, I want you to replace it with 0, 4, 8, and 12. All right, replace that with 0, 4, 8, and 12. Okay, so now when we find the inverse, that means we're going to swap the place of x and y and solve to get y back by itself. Okay, I'm going to jump over to step number 2. Step number 2 is the one where we turn it into x equals 4y minus 16. Okay, now we got to swap everything, get it back to y by itself, plus 16. and then divide by 4. Make sure everything gets divided by 4. Okay, we've got 1/4 x plus 4. We're almost out of time, but that's okay. The bell's going to ring in the middle of this video, but that's okay. All we need to do now is take, okay, this right here down at the bottom in red, that's the inverse. Okay, that's the inverse function. We need to take these values right here and make them the inputs of our new inverse. If I plug in 0, that's 1/4 times 0 plus 4, and it's 4. If I plug in 4, 1/4 of 4 plus 4 is 5. If I plug in 1/4 of 8, that's 2, plus 4 is 6. If I plug in 1/4 of 12, that's 3, plus 4 more is 7. Okay? All I did was I took these x values right here, and I plugged them in for x right there. That's how we did it. All right? That's our test review. The DCA is going to be very similar to this, so study up. It's going to be multiple choice and multiple selection on the computer, all right? So that's all we've got. Y'all have a good day.